Welcome to Let's Calculate Something. We have kind of an unusual equation to solve today. This equation is probably not going to naturally show up. It's more of an exercise type of equation, something that use different mathematical skills, which are handy in really solving natural equations. This one is sort of a made-up equation, but it brings out some really cool things. First of all, we're going to turn this into something simpler to solve, like a quadratic, which I have another video with the link you'll see above on how to derive the quadratic equation. So you can leverage that video to solve this equation. And then we're going to use some exponent and log properties. If you look at the first one, any number raised to a number and then that number raised to another power, equals the number times the product of those two powers. And then the log of a number raised to a power equals the power times the log of the number. And then any factored number or two numbers that are together, it should be like this. Then those two numbers raised to a power equals the individual numbers raised to the power multiplied together. We're going to use those to solve this equation. So let's get into it. First thing we want to do is try to simplify the equation into something we can work on. So there's some tricks in this solution, but let me show you one. So we're going to divide the whole equation by 16 to the x. Okay, so now we've got at least a little more simplification, and I think what we're going to do now is we're going to use this property here to get some further simplification. So we can write 20x as 4 to the x times 5 to the x, and we can write 16 to the x as 4 to the x times 4 to the x, right? Because that factor is equals 20, that factor equals 16. So you can use that. And that will equal 5 to the x times 5 to the x, because that simplifies that. And then 4 to the x again. Okay, so now we can do some simplification. We can cross away, we can cancel these 4 to the x's. Okay, and if we look at this, really, this is 5 over 4 each to the x squared. Right. So now we can do something called substitution. And this is the step that brings this into a simpler form than we can solve, so that we can solve it. So if we take and we let y equal 5 to the x over 4 to the x, then we have 1 plus y equals y squared. Okay? And we can simplify that. Go back to black here. We can simplify that to y squared minus y minus 1 equals 0. And we can solve that with the quadratic equation, which is x, or we should say y, I'm sorry. Start over there. Y equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this equation, a equals 1, b equals minus 1, c equals minus 1. So substituting that in, we get y equals 1 plus or minus the square root b squared, which is minus 1 squared, minus 4 times a, which is 1, times c, which is minus 1, all over 2a, which is 2 times 1. And this reduces to y equals 1 plus or minus the square root. This becomes minus 4 times minus 1 is 4. Times, it's positive 4. Minus 1 squared is positive 1, so this becomes a 5. Okay? All over 2. All right. Now, if we look at this, it's an interesting thing here. The square root of 5 is clearly greater than 1. And this negative number here would not work in this equation up here. And we'll show you that when we substitute back in. But take my word for it, we'll prove it later, that we don't have to worry about this negative exponent. We just have the positive one. All right? So this is our solution for y. Now, we come over here and we said y equals 5 to the x, 4 to the x, right here. Okay, now we have to substitute back in. So that means 1 plus the square root of 5 over 2 equals 5 over 4 to the x, which equals 5 over 4 to the x. Okay, so now we can solve for x. So we're going to use this property now. All right, and that property says if you take the log of 1 plus the square root of 5 over 2, that's going to equal the log of 5 over 4 to the x, which equals x log 5 over 4. Now, solving for x, we get x equals the log of 1 plus the square root of 5 divided by 2 divided by the log of 5 over 4. All right? And so substitute, so if we figure out what this is, we use our calculator. I did that. It comes out with rounding to be 2.1565. And that's our answer. Now, if we had this negative number here, if this was a negative number, the log of a negative number is undefined. So just no solution for that. So that's why we dropped the negative number here. And if you plug this number here back into our original equation, it comes out. It's a little bit different because of rounding. I think you get 395.0797 if you go to 4 significant figures, plus 639.2507. Sorry, 2507. And I think that's off by about 0.2 from 25 to the x. This would be 16 to the x, and this would be the 20 to the x. I think it comes off by about 0.2. So it's real close. If you go out a few more significant figures, you can get closer. But it's a pretty interesting solution how we can take an exponent into a quadratic, solve the quadratic, simplify and lose the negative, and then use logarithms to come up with the actual answer. And so this simple video, which is a little bit unrealistic, shows a lot of cool points in math, and it lets us solve really complex equations by the substitution method. So please like and subscribe, and I'll be putting out some more videos. I hope you enjoyed this one, and put your comments in the comment section.